Okay, you guys. So in this video, we are going to continue on with probability. And I apologize already. I'm really sick, so I'm going to just take a whack at it. Okay, so in this section, we're going to continue on and we are going to talk about unions and intersections. So hopefully you guys can all see this. Okay, we're gonna go back to the old days and just paper pencil. All right. So, unions and intersections. So what is this? So now what we're gonna do, we are going to look at two events. So if you remember, if you forgot what an event was, just look at your notes. So we're gonna look at two events, A and B, both in the sample space. So in the previous lecture, what we did last week, we spoke about what probability was, and we only talked about one particular event occurring, right? But we didn't really talk about two different events occurring at exactly the same time. Um, so, what does that mean? So, you can have one of a couple things happen. So you can have event A and B. So let's say you have two events, right? Here's A and B, right? And if I say this is my sample space, right? So let's say this entire square is my sample space. Here's event A and here's event B, right? Well, if I say event A and B, what I'm basically talking about, if I were to denote it in this Venn diagram, right? I'm talking about everything in the middle. So everything in the middle will denote A and B. So the probability, so the event A and B occurring, right, will be everything in here. You can either have that or you can have A or B occurring. Okay, so that's another option that I can have. Either A occurs or B occurs. So I can still have that. But the thing that happens here is that A or B, what usually a lot of people think is that when A or B occurs, people think that it's either going to be A or B, but not the middle. That's what usually people think. But that's actually not true. A or B, this is still A or B, but it also has to include everything that's in the inside. So basically, it's all of the shaded region between these two Venn diagrams. Okay, so all of that is A or B. Okay, we said this last time. This was only one particular event, A complement, right? This is not really two events, but if you wanted to see it physically what A was, probability of A occurring would be everything in here. Probability of A not occurring, right? Remember, complement means not A, would be everything on the outside. That's what we said. That's all that is. Okay. Okay, so we have A and B and A or B. Now, usually there's some notation. A and B, another way that we can write it is A intersection with B. This is what we call an intersection. And this is what we call a union B. Now, I'm not really going to be using these a lot. I'm going to mainly be using A and B and A or B, so you don't really need to do the unions or intersections, so don't worry about that. Okay, so now these are basically the two different types that we're really going to be talking about, A and B and A or B. Like, how do we calculate those probabilities? Now, notice that I am assuming here that there is some intersection between A and B, that they both intersect, but that's not quite the case, right? So you can immediately have two different events, right, that do not have an intersection, right? This is A and this is B, right? I can have something that they don't intersect. When I have something that doesn't intersect like this, right, we say the following. So if there is no intersection between events A and B, then they are disjoint events. And another way to say it, or another word, is something called mutually exclusive. Okay, that's what we call it. So that's a nice definition for you. So if there's no intersection, so they don't intersect, they have nothing in common, right? Then they are disjoint events. So can you think of something that will be a disjoint event? Well, what's something simple? What do you guys think would be an example of a disjoint event? Well, one example is maybe getting heads and tails in one toss. Okay. So if I get heads and tails, if I roll a coin, right, if I toss it, it's impossible for me to get a heads and a tails at exactly the same time. So that would be an example of a disjoint events, right? Because I can't get heads and tails at exactly the same time. So that's not possible. Okay. So in essence, right, the probability, right? So let me write it down. The probability of obtaining A and B. So if I know that A and B are mutually exclusive, if I know that they're independent, the probability of A and B occurring is equal to 0. So this is only if A and B are disjoint. If I know that they're disjoint, right, then I know that this probability is going to be equal to 0. Okay, that's what we have. Okay. All right, so let me continue on. So hopefully you guys have no questions. Well, I mean, I'm talking to myself, so I don't know. Okay, so here's another question for you. Let me write it down here. And I have this on the PowerPoint, but I'm gonna go ahead and write it down here, just in case you want to see it. So if you have the PowerPoint, you can go ahead and look at it. But this is what it is. So a 6-sided die is rolled. Okay, so I rolled a 6-sided die. So what is the probability of rolling a 2 or a 6? Okay, that is my question. Okay, so you don't need to write this down, but it is on the PowerPoint on Blackboard. So a 6-sided die is rolled. What is the probability of rolling a 2 or a 6? Okay, so now, how would you do this type of problem? All right, so the first thing that you would want to do is try to label your events. So notice that there's two things that are going on, right? I can either roll a 2 or I can either roll a 6, right? So I'm just going to say A is going to be me rolling a 2, roll a 2. And B is going to be me rolling a 6. Okay, so essentially what I'm trying to figure out, right, I want to see what is the probability that I roll either a 2A or a 6B. Now see how clean that is, right? I didn't have to write probability of roll a 2 or roll a 6. I don't have to write everything out in the parenthesis, right? So it's much easier to just leave it like that. So what would this be? Okay, well, probability of rolling a 2 or rolling a 6, well, what is that? Well, in essence, if you just think about it, right, the answer is just 2, 6, right? Because if you can roll a 2 or a 6, right, that's either going to be, well, the probability of rolling a 2 is just one out of 6. Probability of rolling a 6 is also 1 out of 6, right? So that's actually 2 options out of the total 6. So basically the answer is just 2, 6, right? Because I can roll a 2 1 out of 6 times. I can roll a 6 1 out of 6 times. That is equal to 2 out of 6, which in essence is equal to 1 over 3. So basically, what I'm doing is I took the probability of A or B, right? And what I did was I took the probability of A plus the probability of B. And I knew that this probability was 1/6. I knew that this probability was also 1/6, right? And see how it got me 2, 6, same thing, right? So now the thing about this was that rolling a 2 and rolling a 6, right? That was disjoint event, right? They were both disjoints. So because there's no way that you can roll a 2 and a 6 at exactly the same time, right? So if 2 events are disjoint, then the probability of A or B is equal to the probability of A plus the probability of B. That is another formula that you can go ahead and use. Now, do you need the formula? Not really. You can go ahead and use common sense. If you know the common sense way and you can immediately solve this problem with common sense, I would rather you do it that way. You don't necessarily need to do a formula, but I know there's some students that really want formulas, so here's one for you. So this is how you can go ahead and solve for that. solve that particular problem using this. So probability of A or B equals probability of A plus probability of B. That's all it is. Okay. So that's this question. Okay. Now let's go to the next question. Okay. And let me go ahead and pull out the PowerPoint because I actually don't want to go ahead and write this down. Okay. So let me go ahead and minimize this. Go to my PowerPoint. Let's see. Where is it? I was so unprepared. Oh, there we go. Okay. This one. Okay, so here's the question. In a math class of 30 students, 17 are boys and 13 are girls. On a test, 4 boys and 5 girls got an A. What is the probability of choosing a girl, which I misspelled, or an A student? Okay, how would you do this problem? Well, you'll have to find out in the next video to figure out what it was. So what I want you guys to go ahead and do is try to figure this out, right? And in the next video, I'm gonna go ahead and solve it for you guys. But try to go ahead and try it out, see what you can get, right? And I'll go ahead and explain it in a little bit more detail, okay? And I'll also spell girl right, okay?